We're looking at the steps required to solve a homogeneous differential equation of degree 0. So roughly there are 6 steps, starting off with writing the expression in the form of y prime is equal to f of y comma x. So let's rearrange this. So we have dy by dx is equal to basically y cos y by x plus x, this expression divided with x cos y by x. But we have to write in the form of y by x, everywhere y by x, y by x. So here we have y by x, good. But over here this is just y and this is just x. What to do? I can take x common in the numerator. So x times of, if I take x common, this will become y by x. Right? If I taking common, the fun of taking common is divide that particular common factor with all the expressions. So here it is y by x cos y by x. Many people get confused that even we have to divide cos of y by x with x. No, this is a single term. If you are dividing it at one spot with one term, you are done. By default, it's actually dividing all of it, the product of this two expressions. So you just 1x over there, and here it is x by x, which is basically 1. In the denominator, I have x again, cos of y by x. So what happens over here? X and x gets cancelled, and we have dy by dx, which is in the form of y by x cos of y by x plus 1 divided with cos of y by x. So clearly it's of the form f of y by x. Now we're going to substitute v is equal to y by x. So next step would be let v be equal to y by x. So further rearranging, we get y is equal to v into x. Now when I differentiate this as per with respect to x, that is differentiating the entire expression with respect to x, right? I think, let me check, find dy by dx and all of that. Okay, so I just have to go forward. So we are finding dy by dx. So we have product rule over here, dv by dx into x plus v, right? If I substitute in the following expression, so we have the one will convert to, see, dy by dx is dv by dx into x plus v is equal to, so we have this to be v cos v plus 1 divided by cos of v, right? So now what we have to do is a bit of rearranging and all of that, and we almost have the answer. Put all the x at one end, all the v at one end. So if you guys remember, it is to do with method 1, that is, yes, grouping, okay, separating basically. So we have to do that, and we have the answer. For that, first thing is I need to send v to the left hand side, and if I do that, it would be 1, okay, I don't know if you guys are able to do that math. So this is minus v, I need to take the LCM, cos of v, not theta, cos v entire thing divided by cos of v. So this 2 will get cancelled, and we can see that it is simplifying further. So dv is equal to cos v, a bit of rearranging, and we have the following. And after this, you guys know what to do, right? Normal integration, all of that. So the final answer looks like sine of y by x is equal to log of a constant c into x, and that's your answer. This is general expression, general solution, okay, right? So find dy by dx, substitute into differential equation in terms of x and b. That's what we did. This need not be a step per se, to be honest. Let me take a second let me rearrange this. I'm not renumber it actually. Let me take a second. Okay, so this makes a lot more sense actually. So first is we re-expressed y prime and all of that in the form of, well, in this form basically. Then we substituted v is equal to y by x. In that we found dy by dx, substituted into differential equation, that is in terms of x and v basically. Rearrange and solve using variable separable. That's what we did. And post integration, all of that, when we resubstitute v back, we get the final answer. Okay, so these are the steps that we need to follow. Okay, pause and copy this.